Okay, this video is for you if you think you know how to solve trig equations, but you always miss out solutions, or you get solutions that turn out not to be right. Okay, here's an example of where it goes wrong. Okay, the reason why this is not the most basic kind is we've got a 2 in front of the x. Okay, now one thing that some people do is they think they can divide by the 2 and get sine of x equals a quarter. Of course you can't, that 2 is locked away inside the sine, but that's not the most common error. In fact, most people make us do things that aren't actually wrong to begin with. So they think, oh, 2x could be arc sine of a half. Okay, which is 30 degrees. So they think x is 15 degrees. It's psychologically, if you've worked out a value of 2x, it's psychologically very hard to resist going on and finding out what x is. Now, we haven't done anything wrong yet. This is a valid solution. But if I try and get other solutions from this 15 degrees, if I try and do 180 degrees minus 15 degrees, turns out that's not a solution. If I try and do 360 degrees, plus the 15 degrees, that turns out to be a solution, but I've actually missed out a lot of the correct repeats. In fact, this one I'd reject because it isn't in the required interval. Okay, so what's gone wrong is that you've thought about it being 2x as a priority when it isn't. So the way to think about this equation is not to think of it as being sine 2x, think that it is sine of a bracket equaling a half. Okay, and we're trying to find bracket. And there's always going to be a first answer for the bracket and a second answer for the bracket. So when I solve trig equations, it always looks like this. Okay, first value for the bracket, second value for the bracket. If this is just an x, the bracket's just x. Okay, but if this is anything except an x, then just think of it as being a bracket. So the first value for the bracket, okay, well, I've got to inverse sine a half, so arc sine of a half. That's the same as it ever was, which is 30 degrees. And my second value for my bracket, you need to get your method for your second answers sorted out. Do you think about a unit circle diagram? Do you think about the graph of sine? Or do you just memorize what to do? Okay, if you've memorized what to do, you know that the second value is always 180 minus the first value, which is 150 degrees. Okay, and then there may be some repeats. So we always get repeats. In radians, it's 2 pi repeats. In degrees, it's 360 repeats. So things like these, and even more. I've added 360, I've taken away 360, I've added 2 lots of 360, I could add 3 lots of 360. Okay, all of these will be valid answers for the bracket. Okay, now you may be thinking, but all of those are outside the interval. Okay, x has to be in this interval, but that doesn't mean that bracket has to be in this interval. So these actually are not valid solutions, but it turns out that 390 as a value for 2x, and this one here, that should be 360 degrees I should be adding, which is what, for 510 degrees. These turn out to be valid answers because the final step, after you've thought about the first bracket and the second bracket and the repeats, is to remember that all the answers we've found are answers for 2x. So 2x equals 30 degrees or 150 degrees or whatever I've got here, 300 and... what do I think it's... What have I got? Yes, 390 degrees, that's right. Or 510 degrees. All of those are valid answers for 2x, leading to x equals 15 degrees, and 150 degrees halves to 75 degrees, and 360 halves to 195 degrees, and there's my last answer. So these are the 4 correct answers. Okay, so the slightly tiresome thing here is being able to predict exactly which repeats you'll need, and there is absolutely nothing wrong with getting more repeats than you need. And then when these ones here that I've scribbled out, if you try those out, they do lead to answers for x what are not in the required interval 0 to 360 degrees. So you can get them, you can go repeats in either direction as far as you need to until they start not working, and then get rid of those. The slightly smarter way, but it's slightly fiddlier as well, is to actually predict what answers we will need for the bracket. Okay, so the bracket equaling 390 degrees. Okay, although the 390 degrees is not in this interval, it leads to a valid solution. So the way to predict the interval when we're using a bracket, so this was sine of 2x, the key to getting it right is to think of that all the way through as just being a bracket until you get to the very last step. But if I think about the interval for my bracket, if I change the 2x in this equation to, the x to a 2x, I'll just do the same thing with the endpoints. So when x is 0, 2x will be 0, and when x is 360 degrees, the bracket is just 2 times 360 degrees. So you do whatever you did to the x to the endpoints, okay, and you get the interval for the 2x. So now, having got my first bracket, is 30 and my second bracket is 150, and knowing that bracket can be anywhere between 0 and 720, that's how I can recognize that adding 360 to these basic solutions is going to give me more valid solutions for the bracket before I finally remember the bracket contained 2x. So the key to this method is to think of the 2x not as a 2x but as a bracket. Get all your solutions lined up for that bracket. If you want to do this thing where you predict the interval for the bracket, that helps you get exactly the repeats you need. But the wrong thing to do, so remember what goes psychologically wrong is when you think of it as being a 2x, you get an answer for that 2x and you short circuit to an answer for x. These possible adjustments, we can see that this and this one here didn't even appear in the list, okay, and this one here isn't in my list either. This is a valid solution, but it's off the end of the interval. It would have been the next solution if I'd been allowed even larger values. Okay, I'm going to do one more example using the correct method, a slightly harder example, just to hammer the point home. So here we go. I've got tan of a bracket equaling -1, okay, but I don't care about what's in the bracket to begin with. I think tan of bracket equals -1. So my first bracket is going to equal the arctan of -1, which your calculator will tell you. Clearly we're in radians, there are no degrees mentioned, and there are pi's all over the place. Inverse tan of -1, your calculator will tell you, is minus pi by 4. Okay, my second bracket, so I don't care what's inside that bracket, I do the standard thing for a tan. So either using your unit circle or your graph of tan, or just by knowing what to do, we know that we take the first solution, pi by 4, and we add 180 to it, except we're not in degrees, we're in radians, so we add pi to it to get 3 pi by 4. Then I need to think of all my repeats, okay? So I can add 2 pi or take away 2 pi from my answers, okay? And I'm going to do that thing where we actually adjust the brackets. So if I want to know the range of values for 4 theta plus pi, so I do the same thing to the endpoint. So if theta is 0, 4 theta plus pi is pi. So the lower end is pi, okay? And 4 theta plus pi, when the answer is pi, when theta is pi, gives me 5 pi. Okay, so neither of my first solution or my second solution is in that interval. I don't care. I just need to get all the repeats of these solutions that are in the correct interval. So I can add 2 pi to them. So pi by 4, minus pi by 4 plus 2 pi is a perfectly good one. 3 pi by 4 plus 2 pi is a perfectly good one. Okay, so as it happens is minus pi by 4 plus 4 pi. And minus pi, and 3 plus 3 pi by 4 plus 4 pi, okay? Because 3 pi by 4 is less than a whole pi, add 4 pi to it, I'm still less than 5 pi. But if I add any more 2 pi's to it, then I will, both of these do get too big, okay? So these are my possible answers for the bracket. So now I've got all the possible answers for the bracket, so bracket equals all of those things. So 4 theta plus pi equals, I can actually start writing what these are. So 2 pi is 8 pi by 4, so it's 7 pi by 4, and it's 11 pi by 4, and it's 15 pi by 4, and it's 19 pi by 4. Okay, your calculator can add 3/4 to 4 for you and give it as a fraction if you want. And then for each of these, to find what theta is, I'm going to have to take pi away from it and divide it by 4. So for the first one, take pi away, it's 3 pi by 4 divided by 4. My first value for theta is going to be 3 pi by 4 divided by 4 is 3 pi by 16. And then for the next one, we're going to take away, we're going to get 7 pi by 16, and we're going to get 11 pi by 16, and we're going to get 15 pi by 16, and that is how to get the correct 4 answers within the given interval without getting any wrong ones, without getting any gaps in the ones that we do want. Hope that helps.